role of geospatial technology in the new era of development and indigenous initiative. And the workshop is jointly organized by the Scanpoint Geomatics Limited and the School of Civil Engineering, Lovely Professional University. So now I would like to request the presenter of the day, Dr. HarAmrit Sidhu ji. He is the Vice President, he is the President of American Society of Civil Engineering in the North region and is also Assistant Professor of Punjab Engineering College in Civil Engineering Department. He's also has the great teaching experience as well as the industry experience, the working with some reputed organizations earlier like the Roltas and different sectors in the civil and geospatial technology. So I would request to Dr. HarAmrit Sidhu ji, please share your views on the role of disaster management, the applications and the fundamental things. And you have the working in the same industry, so we are requesting. So please start your session, sir.
Thanks, Sanjeev ji. I'm thankful to SGIS and to Sanjeev ji for connecting me for this workshop, and hope my screen is visible.
Yes, sir, your screen is visible.
Okay, I'm audible properly.
Yeah, that's complete.
Okay, so I will start now. Actually, this presentation is basically because you can say that the title is that role of geospatial technology in disaster management. Okay, so in this technology or in this presentation, I am not going to discuss much about disaster, because whenever we say disaster, then we generally know, even a class 10 student, class 7 student also know that what is disaster, that flood or landslide or anything else. But here I will just touch some important points in disaster management, and then I will shift to how geospatial technologies can be used in managing a disaster. Okay, so this presentation will be, for the outline, you can say that this is a disaster. First of all, I will discuss something about disaster overview. Then I will give you some glimpses of disaster, then disaster management, how we can manage disasters, then how geospatial technologies can be useful for the disaster management. Okay, when we say geospatial technology, it doesn't only include remote sensing, GIS, drone mapping, but it's a very wide, you can say, that field. But here I am just discussing remote sensing, GIS, as well as drone mapping, and then we will see some videos also in this, then summary, and then conclusion. Okay, so I will start with some disaster overview. Every one of us is aware that this is a massive landslide which occurs in August 2021 only. So you can see that how landslide is occurring. You can just see this road. So everything settles down. So now you can just imagine what is the, you can say, that effect on the this economy. And since this is a main road connecting two cities, so it's a very, you can say, that very big disaster. So basically, when we talk about disasters, we can divide it into natural disaster as well as man-made disaster, cyclone, floods, terrorism, and war. And what we get from the disaster: significant physical damage or destruction. We can have a loss of life. It can change, it can drastically change to the environment, and it can destroy economical, social, as well as cultural life of a particular area where that disaster happens. Okay, so these are some of the glimpses of the disaster. So when we talk about disaster, you can see, I have taken this from the Google. These are the top 5 natural disasters which occurs. So you can see that in 1556, 8,30,000 death occurs. And basically here I'm talking about earthquake only. So earthquake, that magnitude is 8, and it happens in China. The estimated death toll is 8 lakh. Similarly, when we talk about Haiti in 2010, this is 3,16,000. In Turkey, this is 2,60,000. So you can just see that massive effect which a natural disaster can bring in our society, in our particular area. So you can see that here in China, more than 97 counties are affected. Similarly, when we talk about this, Haiti, this is 3,16,000 total. You can just imagine that effect. This is not only a, you can say that financial losses, but here we are feeling the loss of life also. So estimated death toll is 8,30,000. So we have to manage, we have to go for various techniques, various management techniques where we have to manage these disasters. So similarly, I have downloaded some data from net. This is from the death from natural disaster as a share of total deaths. This is from the year 2013 to 2017. So you can see that in Bangladesh, this is variation, and this India, India is natural disasters are increasing. You can see that in 2013, some natural disaster occurs in India. So the death shoots a lot. Then in 2014, it is reduces. Then now you can see that how it is changing from 2013 to 2017. Here, I have just chosen some of the countries, and it is not rank wise. It is just randomly I have selected some countries, that India, Bangladesh, and you can compare it with the world also. Okay, so this is the world average, then this is Bangladesh, and you can see that this is the year 2013, 14, 15, 16, similarly 17, and you can see that death from natural disaster, this is a percentage wise, the total deaths and with the percentage of the natural disasters. This is a slide showing us that global deaths from natural disaster, that is from year 2013 to 2018. You can see here that all natural disaster includes those from drought, flood, extreme weather, extreme temperature, landslide, dry mass movement, wildfires, volcanoes, etc., etc. Here, I've just chosen these 5 natural disasters, just like earthquake, then flood, extreme weather, extreme temperature, and drought. So you can see that in 2018, up to 2018, earthquake, yes. So in 2018, earthquake is the, am I audible?
Sir, you are audible, sir, please.
Okay. So you can see that in 2018, natural disaster, which is an earthquake.
Yeah, I have requested to all members, sir, please just a minute. Please mute your mic.
Some disruptions are coming.
Yes.
Sir, you please remove him. Sanjeev,
okay,
sir.
I'm continuing this.
Yes, sir.
Yes.
Please, sir,
okay.
continue.
So you can see that global deaths from the earthquake, this is the largest global death. And then if we rank these, then earthquake is the maximum where we are getting deaths. Then from flood, then extreme weather, temperature, and drought. So I have just chosen this, and you can see that this is varies from 2013 2018. So you can just visualize that how natural disasters are affecting our economy or even a loss of life. So how we can manage these things? So when we talk about manage means basically, when we talk about manage, that means prevention, whether we can prevent a particular disaster, and if a particular disaster occurs, then how we can reduce that loss. So basically what we do, we can disaster management, there are 4 disaster management phases. So this is mitigation, preparation, response, and recovery. So basically it starts from capacity building, that we have to mitigate, then pre-impact, then emergency. As soon as a particular disaster occur, then we have to prepare for that particular emergency things. Then we have to restore, just like electricity, just like roads, anything, we have to restore that basic necessities of that particular area. And then we talk about the recovery. Recovery means when we restore everything, then we have to recover or reconstruct various basic amenities, just like roads. We have to recover, we have to reconstruct buildings, etc. So basically, disaster management process has been divided into 4 phases, that is mitigation, preparation, response, and recovery. So when we talk about disaster management, basically there are a number of things which go for disaster management. Most of the things we say generally that we have to be aware that if a disaster occurs, then how we have to respond. But nowadays, using technology also, we are using technology in disaster management processes. We are using different kind of sensors. We are using geospatial technologies also, so GIS, remote sensing, drone, etc. So now I will shift to geospatial technology. That what is geospatial technologies, so that you can understand how we can use these things into disaster management process. And I must share that various government agencies, army, navy, they are already starting, they are already using these technology a lot. Okay, so now onwards, I am shifting to geospatial technology. I'm not giving much time on disaster management because most of you are aware, but yes, geospatial technology I'm going to discuss. So what is GIS? GIS is a geographical information system. So when we talk about geographical information system, you can see that this is the Survey of India topo sheet. Here we talk about a sheet which has all kind of information. Here we can see that there is some water feature is there, we can see some roads are there, we may have some contours, but it's not easy to understand. Although we have all kind of information of a particular area where a particular disaster occurs, and then we have to see which kind of area is that. So with the help of these Survey of India topo sheets, I can get the idea. But what about this? This is a digital map. This is a Google map. So you can easily correlate. You can easily see the difference also. Here we have all kind of information, but I cannot see whether it's a 3D map or a 2D map. Although as a civil engineer or as a different engineers, even as school students know the contours. So if you have studied about contours, then you can understand whether that is that particular area is a hill or a valley, but you cannot understand if you are a layman in this area. So by using this Google image, you can easily understand that this is a hilly area and this is a plain area. So this is the example, or you can see this is the advantage of the digital map. Okay. Similarly, we may have a data which is easily available. It may be a scanned map, but it is not easy to understand. You can just see that maybe we have thousands of villages information, population, maybe education wise, maybe any kind of data, maybe even if it's a disaster data, which I want to analyze, but it's not easy. What about this? This map, this digital map is much easier to understand. You can just see that since this color, this color, this color is different than these colors, so you can automatically understand that this particular color is signifies something else. So that means what? That if I have this type of data, it's not easy to understand, but if I convert all these data into map, then it's very easy to understand. Why? Because I can give symbology, I can give different type of colors, I can do various analysis also in these maps. So this is a digital map. So basically, process of creation, editing, visualizing a digital map is known as GIS. So you can see that process of creation, editing, visualizing a digital map is known as GIS. Now you are also aware that how digital map can be useful. It may be a Google Earth image, it can be a simple GIS map. where we can analyze, where we can give different colors. But remember, this color or this map is location based information. This is not simple Adobe Photoshop map. This is a GIS map. GIS map means they have scale, they have latitude, longitude. So GIS is a system which holds information of geography as well as its characteristics. So when we talk about geography, so in GIS we generally say geography as a latitude, longitude, and when we talk about characteristics, characteristics means its attributes, its properties. That means area has latitude as well as longitude, that is location, and then it must have some information related to its properties or characteristics. So we generally say that GIS is not a map, it's a dynamic and intelligent map. Okay, so GIS is not only a map, it's a dynamic and intelligent map. Why we say dynamic or intelligent map? All of you must have used navigation system. So automatically it will give you that on a particular roundabout, in a particular lights, whether there is a traffic or not. Suppose you want to go from point A to point B, it can give you 2 or 3 options. From 2-3 options, you can select yourself that on which route you want to go. So this is a dynamic as well as intelligent map, as well as soon as you change your route, it automatically change route on the map also. And it will show you that whether you are 3 minutes late, 3 minutes fast. So this is a dynamic and intelligent map. This is not only a map, you can get all kind of analysis. Okay, so this is a system which can capture, which can store, manipulate, analyze, visualize which kind of data, which is known as spatial data. So capture, store, manipulate, analyze, visualize a spatial data. When we talk about spatial data is that data which is occupying some space on Earth. That means what? That means that point, that thing which has latitude as well as longitude. So whenever I am talking about a geospatial technology, we are talking about GIS. Geospatial technologies includes GIS, and when I'm talking about GIS, that means it has a spatial data. That means we have latitude, longitude of a particular point. That means location-based information. This is the base of any GIS or any geospatial techniques. So when we talk about spatial or non-spatial data, this is a non-spatial data and this is a spatial data. Why this is spatial data? Because we have buildings, we have colors, we can write name, and this boundary or this is a particular building, it is occupying some space on Earth. We can find out its area, we can find out length of this particular road. So this is a spatial data. But when we talk about non-spatial data means its characteristics. Just like if I click on this particular building, then you may get this type of information, that some attribute data is there, map ID, what is plot number is 214, then address, then owner name, then what is the, how many floors are there. So you can get n number of attributes, n number of characteristics of this building. Okay, so when I am talking about a geospatial technology, that means I must have a data which is a spatial data, which is a base map. Spatial data means point in which we have latitude as well as longitude, and then of course we must have non-spatial data, because if I want to do analysis that where is a particular sector 44, 43, then how a map can know that whether it's a 43 or 44? That is a non-spatial data, properties and characteristics. One of the best example of GIS, you can just think over any example of GIS. One of the best example of GIS. Okay, so you must have thought we can discuss it later on. In my opinion, the best example is that navigation system which we are using on mobile. So this is also a navigation system which we are using. It's a GIS example only. So already you are using geospatial technologies. Vehicle tracking, so where we can use, where is the bus or a particular vehicle in a particular area, what direction did the bus travel, what speed did the bus move, where had the bus stop, how long the bus stops. So if I have a map, I have spatial data, I have non-spatial data, then I can track these type of vehicles automatically. And in a disaster area, in a disaster affected area, these are very important things. These are the, you can say that, life-saving things when we talk about vehicle tracking. Okay, so emergency services, yes, we are using, since we are talking about disaster management, yes, there are a number of examples. We are using extensively geospatial technologies. It can also assist in identifying trends and patterns. So it is not giving me only a image, only a map, but I can identify trend, whether that particular area is getting affected again and again, or if a particular city is there, then in which part of that particular city is facing those disasters again and again. So we can analyze trends, we can analyze patterns also. We can identify the pockets of special needs, population, elderly, schools, etc. So as soon as we have data, we have spatial data, we have non-spatial data, we can get, or we can identify that type of pockets which needs, which have special needs. We can simulate evacuation scenarios. Before starting evacuation, we can simulate these things so that we can understand how that area will respond. So example, to determine the best location for placing emergency services like ambulance services along a national highway. So geospatial technologies or GIS can help me in this thing also. When we talk about remote sensing, remember here we are talking about geospatial technology. First part, I must say that first class is GIS and another one is remote sensing. So let's see what is remote sensing. Remote sensing is acquiring information about an object on the surface of Earth without coming into physical contact with it. Okay, so what we are doing, we are collecting information, collecting useful information about an object on the surface of Earth without coming physical contact. Remote sensing used to detect, measure, record, and analyze energy reflected or emitted by the concerned subject or object. Okay, even now you are watching, you are seeing this presentation, even that is also a remote sensing, because remotely you are seeing this, even although you cannot touch that presentation, but still you are seeing. And how we can see? Because of energy reflected or emitted by a particular object. Remember that I responds to electromagnetic radiation in the visible spectrum of 0.4 micrometer to 0.7 micrometer. So visible spectrum is this, and we can enable 3D visualization of our surroundings. See here, I'm talking about only about eyes. Here I'm not talking about any technology. Even without any technologies, eyes can see 3D. Okay, but when we talk about remote sensing deals beyond visible region. You can just understand that when we are taking photos or we are capturing images from a satellite, which is thousands of kilometers from the ground, from the mean sea level, and still we are getting a very good image. How it is possible? This is possible because remote sensing deals beyond visible region. Okay, so remote sensing deals with basically beyond visible region, and of course, why we are using this? To collect information, to collect useful information. So basically, we have three types of platforms. Ground-based, here again we are using visible spectrum. Air-based, of course, nowadays, apart from aeroplane, we are using drones, and then we are space-based. So when we are using a remote sensing platform as space-based platforms, then basically we are using beyond visible region. Okay, so remote sensing images, basically you have seen number of Google images. So these are also remote sensing images. Even a Google image that is not an image of Google, that is of a particular, you can say that a sensor, it's a remote sensing image only. So you can see the difference, that depending upon the resolution, depending upon the accuracy, we can use remote sensing images in different disasters, in different projects, in different applications. We can generate a real-time model when we are using remote sensing. Images of different resolutions as per requirements, and true picture along with location-based attributes. Remember, I've discussed GIS also. So what we have to do? We have to superimpose GIS map, digital map on these remote sensing images. So geospatial technologies include GIS as well as remote sensing. So now we will shift to drone mapping. So apart from GIS, remote sensing, geospatial technologies also include drone mapping. Drones, UAVs, most of you are aware, that is unmanned aerial vehicles. Of course, as different application, it also started from that application started from military. Then we are using these drones to commercial as well as recreational purposes also. Why we are using drones? Because this is cheaper than a helicopter aircraft. Few years back, we have to do aerial survey, and it requires a licensing, it requires number of things, and cost is too much. But nowadays we can use drones. But yes, limitations are also in drones. I will discuss that. With the help of drones or UAVs, we can get a high resolution images. Okay, high resolution images means just like images, just like Google Earth you can see. Okay, that resolution is 3 meter, 5 meter, 0.5 meter to 0.5 meter. So depending upon this sensor, that is, if you have QuickBird, if you have wide view image, then you can get a resolution of around 0.5 meter also. But if you have an image of low resolution, that means that Landsat images, which is 30 meter by 30 meter, or Sentinel 10 meter by 10 meter. So we have a, you can say that the number of data sets available, which depends upon the project. But when we talk about drones, we get high resolution images, even we can get a accuracy of even centimeters. Drone can be set up and ready to fly in approximately 20 minutes. It's very easy to set up and fly. When we fly a helicopter or aircraft, these are not environment friendly, but when we fly a drone, these are environmental friendly. I'm working with Chandigarh station for the drone mapping of various areas. There is one project that is known as Digital Land Record Modernization Program. So in Chandigarh, we are using drone mapping for that particular project. Okay. But I have just shared the advantages. What about the limitations? Strong winds, rains, weather we cannot use. May strike a tree or building, replacement may be required. So loss. And main thing is this, that lot of permissions required. Yes, be careful when you are using drones. Since we are using with Chandigarh station or proper government, so there is no issue. But when you are flying drone as an independent or in a company, then you have to be take care these permission, all permission you must have. Okay, so what is a drone survey? Basically, use of a drone unmanned aerial vehicle to capture aerial data with a downward facing sensor. During a drone survey with an RGB camera, the ground is photographed several times from different angles and each image is tagged with coordinates. So remember, when I am using drone, I can place, I can move, you can say I can move cameras to take photograph at different angles, and I am getting image, proper image. That means I'm getting image with coordinates. That means latitude and longitude. So those are geo-referenced images you are getting with the help of a drone survey. Surveying with a drone offers enormous potential to GIS professionals. Yes, remember we started with geospatial technologies. So when we are making a digital map, we require a spatial data, we require non-spatial data, we require remote sensing images, and we can add, you can say that we can add on with drone surveys also. Okay, so what drone is doing, it is enriching a particular digital map. So surveys of the same quality as the highly accurate measurements collected by the traditional methods, but in a fraction of the time. In conventional techniques where we are using chain survey or maybe even total station survey or even a DGPS survey, we have to give time. For a big area, we have to spend number of days to collect information, but with the help of drones, we can do it in a much lesser time. Yes, I must share that when we are using drone can be of different type. The drones which we have, that is the capacity of around 15 minutes of fly, but nowadays one can buy a drone which can fly at around 45 minutes at one time. Okay, so depending upon the drone battery, we can do the survey of a particular area. When we talk about benefits, reduced field time and survey cost, since it is reducing our field time, that means we don't have to be in field for a longer time. So man hours I am saving costs also. It give me provide accurate and exhaustive data. It also provide me real-time data. Mapping of inaccessible areas. Suppose you want to have a project in which you want to go to area which is affecting by disaster, then how you can go? Suppose there is no road, every road or every accessibility is not easily accessible, that roads are not easily accessible, or that particular area is not accessible, then what you can do? You can use drones. Even areas like glacier or various areas, you can easily map with the help of these drones. Geo-referenced images. Okay, so when I'm getting images from the drones, these are geo-referenced images. There is a lot of difference between geo-referenced images and photos. Photos, remember, when we are clicking photos doesn't have any latitude or longitude. It doesn't have scale. But when I am talking about GIS, remember that GIS is a system in which we can capture, store, manipulate, analyze, visualize a spatial data. So that is the main strength of a geospatial technologies, that we can get latitude, longitude. We can get a location based information, okay, which is very helpful whether we are dealing with disaster or even if I am ordering a pizza or ordering a cab, even then location is very important. So in drone we are getting geo-referenced images. may capture real-time images. This is very important. May capture real-time images, the images where you cannot, that area where you cannot visit. You can fly a drone and get a real-time images. Nowadays, there are a number of drones which are of, which can be, which have cameras and used for various type of archaeological survey, disasters, glacier survey. So we can get real-time images even for the, you can use drones for the forest lifetime also, that to understand the forest life, how they are, how animals are moving, how animals are moving from particular area to particular area, other area. So we can get, and we can get 3D images also. Okay, so with the help of drones, we can get 3D images also, and everyone can understand easily that if I have 3D images, then it's very easy to understand that particular area. So if I want to see even that height of the tree, if I have a 3D image, then even I can find out the height of a tree. I can find out how much area or how much that area is affected by a particular disaster. So drones can be useful in a number of ways. There's a voice of this video is audible.
Sir, video is visible but not audible, sir.
Okay. So what they are doing, they are University of Michigan, they are using drones that this area is affected by a landslide, and they are using those things. Then they are saying that how we can generate a digital terrain modeling. You can see, and he is explaining that from the drones, or just like remote sensing images, I am getting a plan, but with the help of drones, I can get a different views also, different view in the sense of the different angle of views. Okay, so you can easily see which area is affected, how much area is affected. Even you can see that difference is there. So with the help of drones, you can just analyze which area is most affected. You can see that this area is affected a lot. So what now it is doing, it is creating a cross section of that particular area. Okay, so we can generate digital terrain modeling. You can see how a drone can help us in understanding the effects of a particular area. So when we talk about disasters and its management, so we can understand that geospatial technologies are very helpful when we talk about disaster management vis-a-vis disaster management. Geospatial technologies helps in inspection of highways, infrastructure, asset inspection, bridge inspection with reference to the disaster. Okay, so in a periodic aerial inspection, help the stakeholders to keep track of their critical assets and avoid catastrophic damage. So what it is saying that in a periodic aerial inspection, so the area which is more likely to affected by the disaster, what we can do, we can take drone images or geospatial technologies. We can make a GIS map. Suppose we make one map on the in January, and then we are updating that map in June. Then again, I am updating that map to December, depending upon our requirement. So since I have a map, I can analyze, I can see how those disaster or those land use are changing. So that I can understand with the help of geospatial technologies better. Remember, geospatial technologies include remote sensing, GIS, drone mapping, ANN, artificial neural network, machine learning, etc., which can be used to mitigate and manage a disaster properly. Okay. This is one of the example that where we can use that flood inundation maps. So for mapping purposes, what we can do, we can make a pre-flood scene and a peak flood image would be compared to delineate the inundated area. So what we are doing, even with the help of Google image, there is a one option of time series button is there in Google Earth. So what you can do, you can capture image of different time period. Okay, so before a natural disaster occur and after a natural disaster occur. So you can capture two images of a same area and then you can compare. So what it is doing again, it is capturing one pre-flood scene and then after or a peak flood image would be compared to delineate the inundated area. So what it is doing, it is comparing those areas to define spatial extent of flood inundation. Since we know that GIS can give me aerial extent also, I can draw area, I can draw line, I can draw point. So if I have two areas, one before flooding and one is after flooding, so I can calculate areas that how much spatial extent, how much area is affected by that flood, to identify the worst flood affected areas. So you can also easily distinguish that which area is most affected and where we have to rush, or you can say that aids for that particular area. To evaluate impact of flooding on environmental concerns such as coastlines, forest, open space, etc. Since I have an image, I have land use land cover map, I can easily visualize, I can easily understand, view that which area is most affected and how it is affecting a particular environmental concern, just like coastline kitna affected, then open space, how much open space is affected. We can plan relief operation also, since we all know that if a disaster occur, most of the time we, if uh, if a particular relief operations are starting, maybe a helicopter has to be land there, then I can understand, I can view at which place is there which is safe to land a particular aeroplane or a helicopter, and then we can even assess a damage. Okay, so you can just see, this is a simple example. I've just taken it from Google, that you can see that this is a particular area. You can see that some water is there. So this is before flooding and this is after flooding. So you can see that even this area is affected after the flooding. So, and this difference in color shows how much area that you may say that how that this particular area is more affected by flood. Okay, so here you can see only this area is affected, and since this is not only a photo, since this is a GIS map, so I can make an area and I can calculate how much kilometer area is there, square kilometer area. Similarly, after flooding, this area is affected. So what I can do, I can subtract that area from the initial area and I can get that area which is affected by this flood. So these type of analysis I can do. I can do various type of analysis also. Okay, so this is some, you can say that flood forecasting, that a foremost requirement of disaster reduction has been enriched by recent advancements of satellite datasets and new methods. When we are talking about satellite dataset, that means here I am talking about remote sensing. So we can have DEM, that is known as digital elevation models. Digital elevation model means I have elevation of every point. Hydraulic model, which is depending upon that how much hydraulic factors are there, then hydrologic models we are creating. With the help of all these models, all these factors, I can create a flood map. Okay, then using land use map, socioeconomic data, and these data can give me some maximum damage map also. Since I have flood map, I can have maximum damage map. Then I can see that particular damage map of a particular area, and then I can go for a risk map. So I can plan for the next year also that these areas are the risk prone areas. Okay, and since we have area that is in square kilometer, so I can calculate the cost also, that which may be incurred for mitigating these things. So we can do the damage calculations also. We can go for flood map calculation, the risk calculation, damage calculations, etc., etc. Okay, so here I am concluding my presentation. So there are a number of conclusions. Hazards, especially natural hazards, are inevitable occurrences which was never and will never be in control of humans, isn't it? Although we are advanced a lot, we have number of sensors, we have number of technologies, just like remote sensing, GIS, machine learning, we have different sensors. Still, we cannot control disasters. But yes, what we can do, we can manage, or we can only try to prevent it. Just like the area which is prone to disaster, which are prone to landslide or prone to flooding, we have to control human activity there. So there are a number of things which can be controlled easily. Yes, geospatial technologies may play a very important role in this endeavor. Recently, these techniques have been widely used. Okay, so here I'm closing my this presentation, and this is the some of the media presence which we are doing, number of projects. So thank you, and we can now session can be open for the participants if any question to you from your side also.
So it's a great presentation, sir, and there's a lot of interesting things and scenarios you have shared, different phenomena, and how can we use the geospatial technology to prevent and manage these kind of things. Basically, you said these are the only things we can prevent the things, not control the things, because it's because of the natural disaster. So the only things the GIS technology, geospatial technology, how can be manage the things, how can we plan, how can we think on planning on the broad way for the future scopes, for future prevention. These are the great ideas, or you can say the planning part from your side. So it's a quite interesting and very important for the education as well. The industry planning.
Yes, even nowadays, most of the government agencies, most of the private agencies, they have geospatial, that you can say that the department in those particular agency, even you are working in industry.
Yes,
so
sir.
You can also share, there are a number of government which are dealing only with this geospatial technologies and using geospatial technology for the managing disaster, for managing number of things. Yes.
Yes, sir. Actually, I'm closely working the NDMA department, the National Disaster Management. These people are very quite using the GIS technology. Day by day, they increases the tools and the planning part. So how can they monitoring? How can they control? If after there are two approaches basically, pre-approach and post-approach. The pre-approach is very important, because we know how we can develop an infrastructure. So after the disaster, we can plan, we can monitoring, and any kind of help from the government that will be provided to these particular locations. That time, these technology is very important.
Yes, I must share one thing. I must share one thing with the participants. I don't know that participants are from civil engineering department only or from other branches also. So I must share that apart from structural engineering, apart from transportation engineering, they must get aware of geospatial technologies also. Because
yes,
whether they are going for transportation, whether they are going for water resources, in every field, geospatial technologies is being used. Even in structural engineering, We are using remote sensing GIS for how much that a particular bridge is moving, how much area, how much a particular area, even for, you can say that NDT, we are using GIS, geospatial technologies, we are using LiDAR mapping. So geospatial technology is an application, and all participants, all students must get some training, must get some, you can say that awareness about geospatial technologies. And I must thank you also, uh, who is taking pain to make aware of geospatial technology for the participants, for the whole of the world. So this is very important, that very good thing which you are doing. I'm really, you can say, I'm really I really appreciate you for these things.
Thank you, sir. Thank you very much for your kind words. And we are definitely we will doing these things day by day. And we know you people are working research area. So we also every time we need you people for your major researches for the particular programs that will be help in the some development, software development, planning development, that will be very useful for you. So I'm really admire your researches and kind of work that we people in
Thank you.
organizing your curriculum.
Do we have some questions from the on the YouTube? It is, I think, live hai wahan pe bhi. Do we have some questions in that from participants or anywhere?
No, sir, there is no much questions. Basically,
Okay.
majorly people are joining through the team, so there is something. So I would like to connect Dr. Janki. Sir, if you have any questions, Dr. Janki, you are listening?
Yes, sir. Good morning, sir. It's a very nice presentation because yesterday students came across a new tool which means almost carries all the necessary tools that we need in general. And today it's an application part, means in which field we can use this geospatial technology. So it's a very good presentation, sir. Thank you.
Thank you.
Okay. If any students have any questions, they can directly ask, or you may write directly to me, or direct to me for any kind of the things. I will forward your query to Dr. HarAmrit Singh Sidhu, so they will answer your questions. So it will be very helpful for your career as well, the planning for the corporate as well, the research part.
Yes.
If
Of
anybody
course, any
students want to
participant, any student can
yes.
connect me. No issues at all.
Yeah. So my details are available in your registration details in the registration forms, or you can directly contact your department, Dr. Janki ji, as well Dr. Ganesh ji, and Dr. Amit Srivastav ji. So you can directly contact with them, and your query will be forwarded to me. I will connect you for any kind of disaster management or any related issues. You want any presentations, you want any kind of the research prospect. So we will open for it. And for technical prospects, if you want to use the IGIS technology, this indigenous technology for your research work, then we will be very happy to provide you kind of the things. So that's all about it. The technology and indigenous appreciated, and the research area in geospatial development. So thank you everyone for your time connecting with us. And also thank you, sir, for your very fantastic presentations. We are very happy to listen to you. Thank you very much.
Thank you, sir.
Okay, sir.
Tuttacele da pari, the Stukara, the मैं बोलूँ रूम सेट था और रूम खाली पर नहीं ना मैं नेटवर्क मत करना मम्मी मम्मी अगले 1.5 घंटा बाद ना ना दे कुछ मत कर यार बहुत 1 घंटा बाद दे अरे यार